this is a presentation about multiple sclerosis and some recent news about a vaccine. So first of all, what is multiple sclerosis? Multiple sclerosis, or MS, is a progressive autoimmune disease in which immune cells attack the myelin in the central nervous system. There's no known cure, although some medications do show efficacy against the disease. They usually have pretty low tolerance and also have side effects. The cause is also unclear, and there are some hypotheses, but none have been solidly proven so far. Symptoms include doubled vision, blindness, weakness, etc., although almost every neurological symptom has been seen in multiple sclerosis patients. Most common in people aged between 20 and 50 years old, although children and the elderly can also develop the disease. Like almost every other autoimmune disease, it's pretty difficult to cure because if you're trying to weaken the immune system, it also means allowing some secondary infections to develop, which could be even more dangerous. So let's go over what occurs at the immune system level in multiple sclerosis. So first of all, T cells have to be able to enter the central nervous system somehow. Usually this occurs by damage to the blood-brain barrier, which is the barrier that prevents unwanted things such as T cells from entering the brain and causing havoc. T cells recognize the myelin as foreign and begin to attack it, which triggers inflammation and a regular immune response. And from there on out, the myelin will continue to be attacked, and ultimately this results in decreased neurotransmission, breaks down the myelin, and could even damage neurons. So now that we understand what the disease is, we can talk about the vaccine. So this vaccine is a modern type of vaccine, which is based on mRNA. There's a few differences between traditional vaccines and modern vaccines. mRNA is usually preferred because it's easier to isolate and easier to scale up than protein vaccines are. And mRNA is very biologically active, so to create an mRNA vaccine, you first need to protect the mRNA in a capsule, and in this case, we're going to use some fatty molecules. And interestingly, many COVID-19 vaccines are also mRNA vaccines, including the Pfizer vaccine. So here's a brief overview of what occurs, how an RNA vaccine works. So first, we have one of two materials, which are both mRNA and with the post-transcriptional stuff attached to it. So here we have NRM, which stands for non-replicating material, and SAM, which is self-amplifying material. And essentially they go into the cell and use the cell machinery to generate the protein products, which are either expressed to the MHC peptide embedded into the cell membrane or secreted as a protein. So the vaccine is an mRNA vaccine, as I said, and once it is absorbed by the target cells, they can begin to produce the antigen. In this case, the mRNA codes for part of a component of myelin. Usually this would be a really bad thing because the last thing you want is for a bunch of myelin to exist in your bloodstream and for T cells and immune cells to be able to recognize it and start proliferating. But in this case, it's slightly different. So normally mRNA uses uracil instead of thymine. But in this case, we have modified the mRNA so that we're using a molecule called M15 or 1-methyl-pseudouridine, which you can see the structures here. This prevents the immune system from causing an inflammatory response, which is what we want, and it increases the tolerance of the protein product to the immune system. In addition, there's also a secondary effect, which is caused by regulatory T cells, which specialize in preventing the immune system from going overboard and damaging other body systems. So ultimately, this results in increased tolerance to myelin, which is what we want in a vaccine. So, so far, we've only tested the vaccine on lab rats, and in these tests, all mice have exhibited symptoms of multiple sclerosis. The treated mice were much less likely to have T cells in their central nervous system than untreated mice, including the placebo group. This vaccine shows specificity. Only myelin is tolerated. Other viruses, other pathogens are not going to be able to be tolerated in the same way. The vaccine can be delivered in high doses, and high concentration doesn't cause an immune response. So this is really big news for a lot of reasons. First of all, as I talked about, many COVID vaccines are using this strategy. In addition, autoimmune diseases could also be cured using the M15 modification. In addition, this could cure diseases such as cancer, which is basically what the essence of immunotherapy is about, like using the immune system to target stuff that we want to kill off. The possibilities are almost infinite. Thank you.